Yeah. Oh, that is. I know.
Yep.
First one, so like type of wiring diagrams, block diagrams, pictorial, schematics. Or we can't see that under.
I can't.
Yeah.
You actually hit play on the slideshow,
Yeah.
then it'll go full screen.
Really?
I think.
How to push play on it?
I don't know.
Okay.
Try pressing the play button.
Well, that's just on this one. See? Bam. See? Yeah. But I can do it here. Yeah. Okay. That one. Next one. Fan. Troubleshooting fan motors. Different types of fan motors. We have the shaded pole. So here, which was it? The motor moves in repulsion and attraction of the stator. Shaded pole motors have copper bands on each pole that provide the required phase shift. So like the.
Hey, I had a quick question really quick. My thing was frozen, so I missed slides 2 and 3.
2 is just a picture.
Oh, okay.
And then 3 was the types of wiring diagrams. So my picture didn't zoom in like I wanted it to. So it showed.
Well, maybe we can come back to 3 like towards the end or at different spots and like relate whatever else you have to the diagram.
Okay.
So you have the ladder diagram.
The ladder diagram
is what's shown there, right?
Correct. Yeah. And that's what like I tried putting a.
Yeah.
Zooming in, but it didn't work. But yeah, the ladder diagram, and this one, it's hard to see, but this was the diagram, I believe, off a refrigeration circuit. You can kind of see up here, that's your contactor. And we'll come back to this one. So back to motors. So the shaded pole motors have bands on each pole that provide the required phase shift. So on the Packard reversible motors, that's what they're talking about there. The ones where you can change from 120 to like 240. Shaded pole motors have the following characteristics: low starting torque, low efficiency, and low cost. And then we'll go into the tech method. So basically tech, stands temperature, evaporator, compressor, and then heat load. I know I've sent Dustin before. I sent Dustin before like a little like tech sheet, and it has basically like on a service call, you follow the steps, and it can basically walk you through the service call, and basically you follow it, and it double not like checks, but you can go through everything and look at basically check temperature, and then you go through the evaporator and check compressor, and then whatever heat load you have on the system. So first one, like temperature, get to like what is the current temperature of the case? Is the case thermometer working, reading correctly? How would you verify this? You walk in a lot of places, like, oh, my unit's temping high. Costco called last week and they said their dairy cooler was 63 degrees, and I got there and looked at the thermometer hanging on the wall, and it's like 60, 65, but it didn't feel like 65. I got my probe, and my probe was reading like 32 to like 35. So, how do the copper lines feel? What does the suction line feel like? What does the liquid line or drain leg feel like? Just like first, like you don't have to throw your gauges on right away. You can check the temperatures of the lines and see what those feel like. How do the return bends feel like at the condenser? So that's another way to tell like the refrigerant charge. To check your end bends on the condenser, you can feel on the side where that actual change of state is on the condenser. So if you can feel go up halfway and it should be hot. If it's not hot at all throughout, then you know you have a refrigerant issue or low on refrigerant or plug cap tube, plug dryer, or something. Or not running at all. How should these lines feel in good running conditions? Like I said, halfway through you should have the 1, 2, 3, like third to fifth end U bend or end bend up should be hot. And then temperature controls. So basically types of temperature controls: thermostat, pressure control, EPR, evaporator pressure regulator, solid state thermostat, EMS controller, and then defrost clocks. Thermostats. Common thermostats we see, and some of this might vary for like our customers and different applications, but like the A19s, coiled and remote bulbs, the Renko A12s, 701s, like the cold controls you see on prep tables, small reach-ins. The common characteristics of a mechanical thermostat: it's basically pressurized capillary tube, bulb, or diaphragm. Differential or range in a thermostat between the cut in and cut out settings. A19 remote bulbs. We see those in low temp and like medium temp. Walk-in freezers, coolers. We don't really see them in like prep tables. Not too much, I guess. If you need
It's been changed out.
to get them or been changed out, and then you see them.
More now, you see the thin A421D or A421, which is the electronic
one.
that took over for the A19.
So on those thermostats, you have the common terminal has a open on rise and close, and then a close on rise. Always make sure it's landed on the proper terminals. You hook them up and think everything's good, and then it doesn't cool till it gets hot or gets low, temperature drops.
Closes on rise.
On the side of the pen thermostats, there's that differential switch. I always leave it alone, never touch it. But they can be set between 3 and 12 degrees by just sliding it up and down. Cold wall cases and chill rails, like condiment bars, prep tables that have the frosted cold rails. visually inspect the frost pattern or amount of frost. So you'll see on the open the rail, look at it, you'll see the frost along the edges. If it's working. If it's not working, you'll see like we're low on charge, you'll see the minimal amount of frost or low frost pattern. Check and see if there is a convection fan used. Some of them have those fans. And then condensate drain. Check for the proper draining and cleanliness. That was the backup. Same one. Coolers and freezers, cold controls. Like I said, this changes. Mechanical T-stats are using a lot. Now we use a lot of like electronic, the ETCs or the 421s?
Yeah, 421.
421s. So all depends on the like techs.
A lot of the
Liking
rails and
or
stuff you see, or the Corel or the Danfoss controller,
the cold rails.
or even on the cooler freezers.
And always check preset for a specific range and differential. So if you have like a new prep table or a new cold rail, just always check and see what the specs are, because sometimes factory doesn't get it right, and you'll have to change them. Renko air over thermostat. That's the one that has a little pigtail round up on top. This style thermostat will be set by the first setting and lowest setting, and then the differential. Low pressure controls. So setting low pressure controls properly, always set the low event first. Once the low event's set, then you will set the differential. And you always want to make sure your gauges are on too, because you don't want to just go by the pressure reading of the control itself. Then you will setting low pressure gauged up. So EPRs primarily used on parallel rack systems, regulating the evaporator pressure to maintain that constant temperature with minimal temp swings. I know like a lot of the racks, but a lot of the some walk-in coolers and freezers, depending on have those set on the certain evap coils as well. EPRs with a suction stop will have a solenoid coil to stop the flow of vapor during defrost. Temperature may be adjusted with a slight turn or pliet screw. This increases or decreases the pressure. I think if you clockwise
Should be more.
clockwise is more, counterclockwise is less. Yeah, and yeah, you
More
want
spring pressure would be less.
the opposite.
Yeah.
Okay.
Right?
Yeah. And then when it said solid state controls, that's meaning like your temp controls like this. So like your Dixel, Carroll, anything like this type of control. That's what it means by solid state. EMS building controls. EMS controllers are used in big box stores, our Costco, Walmart's. I'm not sure if Fred Meyer's has those. It control many systems to maximize their energy savings. So temp sensors are located in the cases, using 5 volt DC signal between 5 volt and 15 volt or 12 volt. Things with the Costco is 12 volt, I think. Right, those sensors, orange sensors.
I think they're 12 volts.
Yeah. Output boards on the case is what cycle the solenoid for temp and defrosts. Then we have our defrost timers. Are wired in series with the thermostat to ensure the system defrosts. Make sure you understand what style and brand you're dealing with. Defrost timers are installed on all equipment that runs under 37. That varies. The 37, like, I mean, 32 most likely, because you're 32 degrees. Your saturated suction is going to be in the 20s, so you have more chances of freezing when you're running that low. So.
Well, and the box isn't gonna melt the ice off the coil.
Applying the T in troubleshooting. So no matter the equipment, check the temps first. Start with your senses. So like you can walk in somewhere and if they say, oh, the prep table's not working, the cooler's not working, like you can smell if you have a burnt light, like something burnt up. You can smell if it's not working, if there's food in there.
It's Panda Express.
Yeah. So like touch the lines, like you can like the saying like beer can cold or soda pop cold or whatever. Like I mean, it has some point to it. Like you can still touch it and like you can tell if it's in that that temp zone by feeling it. Like, oh yeah, it's okay. Then yeah, it seems to be working. Then gauge up afterwards.
If your discharge line is hot enough to give you a blister.
Yeah, and if it's not hot enough, you know.
Yeah.
Then you know. Right. Check your temps. Run your hands in front of the air screens. So that's like on your like open air cases at like your box stores, Costco, Fred Meyer's, Albertsons. Make sure you can feel air.
Coming out of the honeycomb.
I know honeycomb. Yep. Honeycombs can sometimes get dirty. So. Verify your temp with the with your meter. Let's go check. Check your temp controls and make sure they're functioning properly. Temp controller or sensors might be off a couple of degrees. So it might be temp of the case might be reading properly, but the temperature control is 5 degrees off or whatnot.
Especially what the customer goes off of for walk-in boxes and stuff, right at the door. They have those thermostats.
On the side when you open the door.
Yeah,
Mhm.
those are always way off.
And that's what they check the temp with. Oh, it's reading 45, and
Yeah.
they just got in stocking or whatnot.
Or their hinges are bad and the
Mhm.
door closure's bad.
Yeah.
Shut.
So that's the that's all for T. Anybody have any questions?
I got one.
Yeah.
What kind of differential should you have on a cold rail? Like generally.
I guess like manufacturer specs, but I don't know. I'd say generally like
45 degrees.
yeah, like
Because
4 to 5.
your food still has that same 5-degree differential that it should be in, right? Our goal is like 34 to 38. So if you're keeping your air temp between there, then you're good to go.
Why does Joshua's thing look like Travis?
'Cause he made it that way.
No, they changed all their pictures like a couple months ago.
Josh, do you have anything you want to add to that, or like you have something in your mind or something you encountered that maybe someone else has encountered?
That's kind of why I asked the question, just so everyone would kind of know, like, hey, you want to keep it like in a food grade temp. So just like they answered, which was I thought they would answer, like between 34 and 38. So if your set point is 34 and you have a 4 to 5 degree offset, it's going to keep it right, the food right where you want it. So I just asked it just so they would say the answer more or less.
So next one, evaporator. When checking the evap, we should be checking a few items. How's the frost pattern, ice pattern, sweat pattern look? You can tell, like looking at the evap, you can tell most of the time, like if you have if your metering device is working properly. So, is TXV metering device feeding back correctly? Like if it's too, are we flooding back? We have too much or too little refrigerant. So, how's the suction line leaving the evap feel like? So, is it covered in ice, or is it not like? Is it sweating? How's the suction line entering? Or how's the line entering the evap feel? How's the airflow? So is the fans dirty? Coil dirty? Fan blades dirty. I forget
It's like
what percentage like of dirt
30% or something like that.
on the fan will cause that, like cut down on that airflow, which if you have less airflow going across your coil, then you have less movement and cause of the refrigerant. Coil freeze up or whatnot.
I'll just say too, because of the fan blades, I mean, you figure that little bit of extra weight. That's why it's so important when doing PMs to pull the guards off and clean the fan blades. Don't just brush the coil, but take it apart and clean it all so you have that maximized airflow.
Well, and you lose life of your fan motor as well, because you put all that extra stress on that motor's gonna die a whole lot sooner than it should.
Mm-hmm. Frost, sweat, and ice pattern. When checking the ice and sweat pattern visually, recognize the difference between good and bad pattern. Different cases, coils, and equipment have different acceptable patterns. I tried uploading the pictures. I had pictures, but I couldn't get them uploaded. But if you have you can see the symptoms. If the frost pattern is too heavy, then you have issue. Too less, then you have issue. So too heavy, you have too much refrigerant, too much superheat. Superheat.
Not enough superheat.
Not enough superheat going to the evap.
So too much refrigerant if the
Going
frost is too
entering.
heavy, because it's evaporating in the suction line after the evaporator.
Come back. Metering devices. When examining your evaporator, without gauging up the system, what are some ways to know a metering device is feeding properly?
Superheat not adjusting.
Check your superheat, like Matt said.
Yeah. So like, if it's not adjusting all the way, you're going in, you're waiting, watching it, going, turning it back out, and if it's not doing anything, just stay in the same temperature, then we know it's not feeding right. When checking expansion valve, how do you check? How do you check the power head? How do you check and see if check the valve for non-condensables? So like, maybe the system have non-condensables in it. I forget which one's the TXVs with the screens. Remember the model? So like some of the TXVs that have the screens on them. So pump the system down, and you can check the screen. If the screen's all solid black, like the one I found last week, then we know
That nobody put nitrogen.
we don't know if there's nitrogen or there's a lot of acid in the system or something. So
I would encourage too, if you ever do have a case that has high superheat, to pull and check the screen and clean it before opening the valve. You figure a week or two ago the valve was maybe running fine, like something obviously changed. It's not always the valve. Same thing with like flood back. If something's flooding back really bad, your coil gets full of liquid, it can actually give you like a false high superheat. So like one thing I always did is, like, before I adjusted the superheat, I always valve the case off and let it pump out of the coil for a few minutes and then open it back up and start fresh. So I don't have either a completely starved coil or a completely flooded coil. If you have if you have your hand valve closed and pumped it down or whatever, at that point you might as well pull and check the screen while you already have it pumped down. And then, before you adjust your superheat, you're always starting with a fresh, clean screen, and your coil's going to be warmer. It's going to be needing the refrigerant, so you'll see the valve fluctuate like it's supposed to.
Yeah, that happened at Costco on those meat cooler. we replaced the TXVs, adjusted everything. Rack A has a lot of crap and acid in the system, and the screens keep clogging, so that's creating floodback going to the rack. So,
Hey Dustin, quick question. Remember you always told us to cut the pigtail off the power head to see if it's faulty.
I did not ever tell you that. That's a load of horse shit.
But you can't hold the bulb in your hand and see if you're.
If it wasn't Matt Garabrandt, I would have been like, man, if I ever told you that, if it was at the company Christmas party or barbecue and I was drunk off my butt, I probably wouldn't have taken my advice.
But like Derek said, you can, if you're having trouble adjusting, take the bulb off the line, stick it in warm water, or hold it in your hand, and adjust it, and see if it
Not necessarily adjust it, but just see
if you can feel
drops after it warms up.
While we're on the topic of expansion valves, I mean, we run into it a lot of older stuff. Like, does everyone on the call know that if you ever don't know what your gas type is, that a good place to start is to check your expansion valve, see if it's got the little clip on it that tells you usually sometimes, like the manufacturer specific ones, the valve itself will indicate a refrigerant and the power head indicates a refrigerant. So if you're ever not 100% sure, you can always go to your valve and see what your valve's rated for as well.
R12, baby.
Yeah, if your valve says R12, I would highly advise not going and picking up a jug of R12 somewhere, and you'd probably have to get it from some guy's basement or garage on the internet, but I'd probably assume it's probably not that.
Dude, I have a guy that makes his own.
Perfect.
I like to just charge it with straight chlorine.
Recognizing good frost patterns should be even throughout the coil. So not like heavy on the bottom or heavy on top.
Indicates low charge, right?
Low charge, flood bed. Frost pattern should be light and minimal, allowing air to still pass through the coil. Because if you have too much frost, too much ice, like your coil, and you have your fins, I mean, there's not actually that much space in between those. So if you have a lot of frost, then you're not getting air through it, which is gonna cause ice up. Off subject, but still like talks about the frost pattern. So like ice machines, goes same thing. Like the ice pattern, it should be even on the plate. It should be even on the plate, not not ice getting built on top of the evaporator or ice being built on the bottom. So same, the same effects on that too. So in that same thing, if you have an ice machine, we have ice being built on either top or bottom, then we know it's either a refrigerant issue or metering device issue.
I'd also say too, like I've made this mistake, like when I first started doing this, like, you know, a lot of times frost, it correlates to flood back. A lot of people see like heavy frost, like on a suction line and think like flood back. Don't just assume that it's flood back. Like always verify by like checking your superheat, because frost accumulates by a lot of other things too. You know, your suction line's cold, you're in an old grocery store, the insulation's all peeled off. And, you know, if it's humid in the store, like that's going to accumulate more frost. So, you know, if you ever do have like a frosted up suction line or whatever, like still always verify your superheat. Don't just go right to turning your expansion valve in and assuming it's flood back.
And check your charge on your system too, because if you're low on charge, then you're going to be.
Your metering device cannot meter a gas; it can only meter a liquid.
So then you'll be off and all that. Walk-in coolers and freezers. Visually inspect the OEM provided thermometer. So walk-in freezer cooler on the side, right when you're walking the door, like those thermometers. Check the temperature. I misspelled that, said multimeter, but check it with your thermometer or probes. Visually inspect coil for cleanliness and frost pattern. Visually inspect motors, check and see if they're running and clean. If you're doing maintenance, any motors you see that have like the dirt or oily stuff like leaking or whatnot, like mark that down, because it's gonna go bad and go out, and that could save a trip, save a customer overtime charge or weekend charge. So check discharge air temp. If iced up, inspect defrost components and condensate drain. So discharge air temp, your TD across the coil as well. Iced up, check your if it's walk-in cooler, has a defrost clock, check your time, check your time. If it has heaters, check your defrost heaters. Make sure your heaters are working properly. Condensate drain. Make sure your drain pan or condensate line is not plugged up or has crap in it. That can start causing your bottom of the coil to freeze up, go higher, and until you pop something. The coolers. Basically check your, like on your box stores, grocery stores, check your honeycomb in the cases. Check the airflow. If you can, pull a section of the case and visually inspect the coil for cleanliness and frost pattern. Certain stores Like they wash their own coils. Costco. I know Costco does. I don't know about Smith's.
Matt G, do you have a question? And then I have something to add.
I do real quick. So we briefly touched on the subject, but I didn't really hear much feedback or answers to it. And that would be ice pattern builds up on, say, a walk-in coil. Say it's just the bottom half. Say, say it's around the TXV. What are the symptoms of certain failure points? You know what I mean? Obviously not like a drain pan heater. We know what that looks like, but say a clear ice buildup as opposed to frost, white ice. You know what I mean? Does anybody have answers on what those can be?
Yeah, it's like different, like if you have like a heavy frost or like say a light clear frost. Is that what you're talking about, Matt?
Correct. And also, there's also times where it's just the whole bottom half of the evap's iced up, but the top isn't. I'm wondering if anybody has answers on diagnosing points on that.
So if and correct me if I'm wrong, anybody, but like clear ice or like the melty ice, like can be like humidity issues or them leaving the door open or walking open.
And I would assume that's not like overnight shit. That's shit that's been going on for weeks, right?
Yeah, and they'll tell you, oh, that just happened this
Or
morning.
so let me add something on that one. So your clear ice like that, most of those freezers have a drip time. If your drip time is too short, it's not allowing that ice or that water to dissipate. So we'll collect at the bottom of the tubes and then freeze at the bottom of the pan.
It'll just melt, freeze over and over until it builds up, correct?
Yes.
I've noticed too, some of my experience, some of like the thicker, heavier, I guess, colder type ice, if you figure you're flooding back or you have low superheat, if you figure that coil is just saturated and it can't evaporate that liquid, I feel like I've noticed like kind of the heavier ice build up, like if you're low superheat, and I feel like if it's starving, I feel like the frost pattern's a little like softer and more like flaky, like it's just like desperate for liquid. And that's the type that it restricts airflow super quick because it's just building up frost, but the second you pour some water on it, it's like boom, gone.
It's like snow.
I feel like that usually is more like your expansion valve starving. And like we were saying, there's lots of scenarios. John mentioned drip time, but like another thing is defrost termination. How many of us have de-iced a freezer, throw it into defrost, took a quick amp rating and was like, oh, my heaters are working, must be good. It's probably a clogged drain. But a lot of times, the typical setup is the termination is the first point of ending the defrost, and the time clock is just a fail-safe. A lot of freezers terminate based off of temperature, not off of time, and the time's like a backup option. So if your termination is your Clixon's encased in ice, I mean, you figure ice is what, 32 degrees. If your defrost termination sensor is sitting there encased in ice, it's probably sensing 32 degrees, not the actual coil temperature. You might defrost too soon. Same thing with a faulty defrost. Like that's why it's important, like when you de-ice something and you are testing defrost, like, yeah, verify the electric heaters are working, but look at the time clock, like run it through a full defrost. If your time clock's a 40-minute defrost and you're terminating at 10 minutes into defrost and your frost pattern's not off your evaporator, your termination Clixon's not working correctly. So you have to really dig deep in that and verify that, it's the other side of it is extra moisture can cause ice buildup. So if your ice is gone after 20 minutes and your termination Clixon hasn't kicked it back into refrigeration and it's set for an hour and a half, well, guess what? It's going to start getting steamy in there because your time clock's not going to kick it out. So it's not always just like the time clock. It's, it is like what's your superheat and what's your feeding pattern and what's your airflow like? Is there boxes stacked up all the way to the top that's restricting it? Are your fan blades super dirty? But, it's not always just a simple, oh, my heaters are working, I'm good to go. And also, if you are de-icing it, you got to get all the ice out. The center mount coils, I'm sure you guys have all probably seen those. I remember when I was in Reno, I had a guy go in to de-ice a freezer. He told me like 20 minutes later he was all done, and I was like, no way, like there's no way you're all done. And he's like, yeah, like I got all the ice off. So I go in there, I'm like, he's like, see, I'm all done. And yeah, he got all the ice off the outside, and I shine my flashlight up in the inside, and it looked like a freaking iceberg in the Antarctic Ocean up there. I'm like, no, you got to turn it off, take the guards off, take the blades off, and like you got to hose out the inside too. Um, and then along that, termination side of it too, when we went to the KE2 factory in Missouri, the guys had said the same thing over and over again regarding defrost. It was like, temp, or what is the ice, melts, last, right? If you're in like a grocery store and it's got an actual temp sensor hooked up to an E2 or a Danfoss controller and it's terminating defrost based off of that temp sensor, obviously your coil temp's going to be different. Is the top colder than the bottom? Is the left colder than the bottom? Your expansion valve's only on one side. So if you do have a termination clicks on or sensor, it's got to be on the coldest part of the coil or the coldest U-bend, because if it's on the furthest away from the expansion valve, or it's on the warmest part of the coil, or it's near a defrost heater, it's going to get to temperature and terminate before all the other parts of the evaporator have defrosted.
Awesome. Thank you.
Thanks, Dustin.
Yeah.
Ice machines, so evaporator. Check the ice pattern. Check the ice pattern. Perform a production test on flakers and nugget machines. Does everyone know how to do the production tests on ice machines? Like Hoshizakis and Manitowoc's?
Yes, sir.
You want to explain it briefly since you didn't get yeses all the way around?
Yeah. So basically on the Hoshizakis and Manitowoc's on Keebers, from start, so from moment it kicks out of your harvest, you time it from there all the way till it drops and starts the next recycle. Manitowoc and Hoshizaki both have their specifications, what their time should be, in manufacture. If you're at, say, any Costco, or they have the big trays, or one of the big dish pans, put that in and catch the ice. You catch all the ice that falls, and then you weigh that ice, and then you do the calculations of how much that ice should weigh, and whatever that weighs, you times it by their calculation, and then that will tell you how much ice should be dropping in a 24-hour period. So like the Hoshizaki KMS 2000s should be doing 1,800 to 2,000 pounds per day. So if you do your calculations, it should be reading that. If it's reading 1,500 or 1,000, then you have either water issue, not enough water, or you have something refrigerant issue. So
not to go back, but can I go back when you're talking about the cases for a second?
Yeah.
If you guys, I don't know if you guys have ever noticed it. I'm sure most people that have been in supermarkets or convenience stores have, but I'm sure you guys have seen the self-contained coolers or whatever at a gas station or a Smith's or something, where it's got the Matt was talking about honeycombs earlier. But a lot of these case manufacturers, not only they have the honeycomb, but they put a baffle in the back of the case. I've seen it in the back, behind the back wall down at the bottom. I've seen it in the back behind the honeycomb. Does anyone know what I'm talking about? It's like a honeycomb. It's usually metal. It's part of the case, and it goes the entire length of the
Yeah.
case, and it's got a bunch of little holes in it. And those holes love to get filled with dirt. So if you're ever having like, it seems like you cleaned your honeycomb and everything seems to be working good, but your airflow's weak, or you're just not getting the airflow that you need, or your air curtain's not strong enough. Just keep that in mind and like look for it. It can be a real bitch to clean. I've had to take the back wall apart. I've put in a little hose on my CO2 thingy and shoved it down the little holes in the back wall of the case and blew them out. And they get dirty quick, and they're not very big holes. And all it's really designed for is to allow even spread of like the air moving up the case. And so if you're ever working on like those open air reach in style coolers and stuff, just keep an eye out for it if you ever are cleaning a case or have low airflow. Because I've ran into that issue a lot.
Yeah, and I've also had the same thing like that, but multi-decks, deli cases, deli and dairy. We had an instance where we thought we had plugged honeycomb because the coils kept freezing. Well, we ended up taking the whole back wall off because the coil was in the back wall, and we found old expired, some of it was 7 years old, food that had fallen back, product that was on top, cheese, bacon, sausage. It was pretty gross, and it had restricted airflow, and that's why we weren't having any. Well, that's why the cases were freezing, because it was off-cycle defrost, baffling a lot of people.
That sounds like the mysterious bacon demon at the old Safeways in Colorado.
Yep, that's where they were.
Oh. So can everyone see? It's hard to see, but back to the TXV, what Dustin was saying, like, and the stamp on the top.
What's that?
What power head do you have right there, Matt? And you can post the picture in the chat on this group.
Oh, I can? Okay. Let me try.
And what does the power head say on that one?
Yes, this one's the KT43-SZ.
So what valve do you think, kind of a refrigerant do you think that the valve is designed for?
There you go. I put it in the chat, guys. So is it medium temp, low temp, high temp? So it's gonna be low temp.
So does anyone know like what they distinguish as like low temp or medium temp?
The refrigerant type.
So this is primarily used for 404. And then do you guys know what indicates low temp or medium temp? Anyone? Josh, do you know?
Oh, sorry, I was trying to get back to the chat. Yeah, usually the letter indicator on which refrigerant it is will tell you what temperature that refrigerant will do. So like that 507, I was trying to go back to the picture, but usually the letter will indicate what range that refrigerant will do. So
Which letter?
Say again?
Which letter?
After the number, usually there's a letter like the 507A, that's a low temp. But usually when I see a 404, I usually think it's going to be a low temp
Mhm.
because primarily that's what it is.
So I don't know if it's like just coincidence or not, but I was kind of curious just because, you know, a lot of times guys will be like, you tell a guy to check the valve and it lists 4 refrigerants on there and like, oh, like I don't know. So I don't know if this is like, again, I'm not saying I know, I'm more just like triggering a conversation. But from what I'm finding, it looks like that most of the valves ending in a C are listed as like higher temp applications or like medium temp, and everything ending in a Z is pulling up as low temp. And then I'm not sure, like, does anyone know like what the KT or the 53 is? So if you type in 53 SC, it's a 404 medium temp valve. If you type in 53 SZ, it's a low temp 404 valve.
Mm. Neat.
Yeah, the Sporlan kits.
Yep.
And then Ken posted the chart too, Dustin.
So let's see here. Trying to get back to the chat thingy. All right, Ken, what are you finding out?
So KT is the kit.
Yeah.
So the 43 is the element size number. The next letter is refrigerant code.
Which this TXV doesn't have.
This TXV does have a refrigerant code. What's the refrigerant code on
Yeah.
the TXV, Matt?
So the KT dash 43.
And then what's the next letter?
I can't
Next
spell.
letter is
SZ.
So
SC.
what does S signify?
We're gonna go to our chart here, which I haven't gotten that one put up on here yet.
It's on here. S is the 404 family of refrigerants. So I
Yes,
believe.
so you.
I know it's on here somewhere. I don't think it is because this is a OEM using the build.
Yeah.
That's not a build.
But it should tell me which one I need. Right?
Mm-hmm.
So it'll tell me which one I need. So S's would be,
If I recall, S is usually 404, so an SC is going to be medium temp, and an SZ is going to be low temp. And then I think like the V's are the 22 valves. So V's would be for anything like 22 or like a replacement 22, which I think is your chart say like 448, 449, probably
so
407, anything that replaces R22.
507 and 404 only.
Yeah. So I don't know. Hopefully that helps you guys a little bit because I feel like we run into that a lot. But we don't know what gas to use. And you hear, like, I remember when I first started, you always just heard like all the veterans guys say, well, go check your valve. Like, I'm checking my valve. The stamp's all worn out. It's all rusted. I don't know what the hell I'm looking at. And the power head tells me like 5 different things. Like, what is it? You know, I don't always know the cartridge size. In Ken's picture, there's a little silver pin. If you ever change an expansion valve, it's going to come with that. Please put it on like the cap tube because it tells the next guy what cartridge size. Obviously, your cartridge size is going to probably be more like regarding like the flow and stuff like that. But at least you have an idea. If you don't know, at least if it's like a VC, it's probably an R22 medium temp valve. If it's a VZ, it's probably an R22 low temp valve. And if it's an SC or SZ, it's probably 404 or 404 related refrigerant. So I don't know, just feel like something we probably all encounter fairly fairly regularly and aren't really sure how to proceed. So hopefully that helps.
Thank you, Dustin.
Thanks, Dustin.
Hey, Dustin, real quick, that what
Well, he had a thought and then it was gone.
Lost in the waves.
Anyone else have any questions regarding, refrigerant identification from like expansion valves or anything like that? Like Ivan or Michael or Jeremy or whoever else is on this call?
No, Joel and I recently did a walk-in cooler, and it had a TXV on it that was 30 years old, and it was for an R22 system. And one thing I learned was that you can get all the information off the head of the TXV, and that we substituted with R422B, but it was still compatible with an R20 with the R22 refrigerant. But yeah, it was just cool because you couldn't find that TXV anywhere. But we had a supply shop make one for us, and all we had was just whatever was on the head of the TXV, and it worked.
Yeah. I know a lot of us, we've all been there. We've all had a bad valve and we reach out to Parts Town or whatever to try to order the OEM. But it's all usually going to be a Sporlan valve or a Danfoss valve. And if it's a Sporlan valve, you're going to be able to find the body type, the power head type. You're going to find everything you need at the supply house. That's a lot better than paying double the price and then waiting for 4 weeks to get an expansion valve that either you can have the parts house make or you can make yourself.
Oh, she loves Danfoss.
Thanks, Dustin.
Supplier has Danfoss. TXVs.
Or RSD.
Get them.
So back to the ice machine evaps. Shut off the water and let the evaporator dry and check the cleanliness and condition of the evaporator. You can see how much hard water, scale, or even check and make sure the nickel isn't coming off. Verify water flow meets the ice machine requirements. I uploaded a picture of water filter. Some places, some restaurants or ice machines have them. Check the pressure, and then refer to the installation instructions on the ice machine. The specs will say how much water, what minimum water, and what temperature of the water. Like Hoshizaki, inlet line has to be 1/2 inch, can't be any less. Manitowoc, you can do the 3/8 compression fittings. So like the compression
Little quick connect.
yeah, yep. So
keep in mind too, when Matt says like 3/8 and 1/2 inch, he's referring to plumbing sizes, not refrigerant sizes.
Correct.
1/2 inch to a plumber, like I believe in refrigerant, we're always talking about outside diameter. So when I say 3/8 pipe on this filter dryer or a 3/8 filter dryer, the outside of the pipe is 3/8, which means the inside of the pipe is going to be even smaller. Where if you're a plumber and you say 3/8, you're going off the inside diameter. So, you need a 1/2 inch inside diameter. For whatever reason, like, we've all seen those ice machines where they're old and whoever installed them, they have copper ran to them instead of like PEX or PVC or whatever, or like a braided hose. 1/2 inch to us is pretty much 3/8 to a plumber or whatever the next size. I think it's 3/8, so the next size down. So 1/2 inch to a plumber is going to be 5/8 in refrigeration piping. So based off whatever vendor you're at, if it is copper and you need like a fitting or whatever, and you're like, oh, like Matt said, to get a 1/2 inch fitting, if you go to RSD and get a 1/2 inch fitting, it's going to be too small. So just keep that in mind, like the difference between like water lines and plumbing, measurements, and refrigeration piping measurements.
Mhm. Next one, like air conditioning, inspect the air filters, check dates. Depends on if we do the maintenance or whatnot. Check and see what the dates were. Check the blower motor and belt. Check the back to the sweat pattern. Same thing goes in line with the air conditioning. Check the sweat pattern, frost pattern, and cleanliness. Frost pattern on, so like air conditioning is high temp. We're not running, or it's not like a walk-in cooler freezer. The evap's not running at 20, 25, 28 degrees for your saturated suction. We're running 35, 38, 40. Like
If I see less than 40,
40.
I generally look for an issue.
Yeah, 40 degrees. So if you see a big frost pattern, like you would see on a walk-in cooler on air conditioning, there's issues. Check the drain pan, cleanliness and proper draining. Check aluminum filter, if there's an economizer and if it's used.
The aluminum filter, you're meaning metal filters on film.
Correct, like the outside air filters there, the 1 inch, like 30 by
But sometimes
half
a real
inch or
thin.
whatever.
Yeah.
I would say a big one on air conditioning too is, like you mentioned, check blower motor and belt. But I think like motor amp draw and like the speed the motor is running is really big on air conditioning.
Yeah.
If your motor is not, like obviously motor speed too, a lot of that has to do with the belt. How is the belt tight? Is the belt the right size? Did someone adjust the pulley and put a bigger belt on it because they didn't have the right size? All those things like factor into it. So like if a unit is in cooling mode and your motor is not running fast enough, what do you think is your suction pressure going to be higher or lower than normal? And is your evap temp going to be higher or colder than normal?
Mm-hmm.
Which one is it going to be higher or lower? Does anyone want to guess or no?
Higher.
Lower.
Lower. If your
Lower.
motor is moving too slow, you're not moving enough air through the coil. So your coil is going to sit there and have that refrigerant sitting there cooling it down. I've ran into this a lot when I have iced up evap coils on AC units. You de-ice it, you turn it on, everything seems like it's fine. The suction line's good and cold. If your evap temperature is dropping below that freezing point, there is no time clock on it. This thing will run until it satisfies. And once that frost starts building up on that coil, it's going to get worse. So now you have a restriction, and now you're never going to reach set point. And again, there's no defrost, so it'll keep running and running and running. And now your coil's getting more and more restricted. And next thing you know, you have a big ball of ice and you can't pull the filters out because they're stuck to the evap coil. And so, I'll always check like motor speed. And it's like the same thing for heating mode. I'm sure you guys have all probably looked at like some of the residential furnaces, some of these rooftop units. If you've ever noticed, a lot of the fan motors have a high speed and a low speed. Usually the low speeds for the heating and the high speeds for the cooling. If you're moving too much air through it, if you're going full speed ahead and you're trying to heat, you also have, your economizers letting 5% of the cold air in, and you've got all these different factors. Like now you're not building up enough heat to get a proper like supply air to heat the building. And so, yeah, it's great. Your motor works and your belt looks good, but is it the right belt? Is your motor pulling the right amps? I always look to see like what the amp rating for the motor is, and then check my own amp draw. A lot of these units too have an adjustable pulley. Usually the pulley on the motor pulley is usually adjustable on a lot of these. It's got 2 Allen heads. You can loosen those heads and you can actually twist your pulley to move it closer together or further apart from each other. And that's going to affect where your belt sits on that pulley and is going to increase or decrease the distance the belt has to travel going around, which will
Okay.
alter your amp draw and your fan speed as well.
Hey Dustin, do you remember what is it? The pulley inward is higher amps?
If
Or is it out? Do you remember?
I think if you open it up more, it decreases the distance around and I think lowers amp draw.
Yeah.
If you twist it in, it tightens it up and stretches it out and increases
Amp
the
draw.
amount of distance it has to travel. And you know, I've dealt with some where I've fought it and I've gone as far as I can go, and now I can't get the belt on because it's too tight. You know, chances are it's not the right size belt for that unit if I'm still not achieving the proper amp draw on my motor. So just because there's a belt on it and just because it's running, you know, the amount of air you're pulling through your evap coil is like really critical on air conditioning. And I
Side note,
kid you not, I've seen people, I've walked up to an RTU where someone has installed a defrost time clock to turn the unit off at different times of day to allow it to defrost rather than just having the right size belt and pulley on the unit.
Nice.
It's creative.
I mean, it got the job done, kind of.
Huh.
I think I'm gonna use that.
Defrost block on everything.
Did you have
It gets the job
some-
done until someone goes behind you and goes and tells your customer, whoever did this is an idiot. And then we look bad. I love being the person to go to the customer and say, I don't know who you guys were using before us, but man, they, rather than doing this, they threw a time clock on here. They probably charge you $500. And, you know, if you ever feel like it gets hot at random points in the day, it's because your AC unit that's not supposed to be below freezing is in defrost.
Oh, it was you guys.
And Josh, I didn't mean to cut you off. You looked like you were going to say something.
oh yeah, I was just gonna add just a couple items. As far as airflow issues, if it isn't any of those things, always to check check your return vents. The grills will plug, which will slow your air down, and then also the valleys inside the blower wheel. If they fill up with dust, you're also going to lose airflow because it can't scoop it to move it.
Mm-hmm. That's true. Cuts the efficiency down.
Yeah, because it'll still spin, but if the valleys are full of dirt, no air is going to be. It'll still move air, but it won't be as much.
Yeah, it's just like your fan blade on your walk-in that we were talking about. That debris affects how it runs.
So like back to that, Josh, like how many of us when we do a maintenance look at that? When we pull something,
None of us.
change the belts, do we actually look at that? Because
No.
I bet there's a lot of stuff that's like terrible.
Yeah, I mean that's just like one of those things because you got to turn it off to change the belt, or
Mhm.
even just to look at the belt to see if it's cracked. But yeah, just glancing at it, if it looks dirty, then it is dirty.
Yep.
But literally, you should just see the metal when you look at it.
That color's the metal. It isn't brown.
Matt Garabrandt's back. Matt, what was your question earlier? Do you remember?
Let's try this again, guys. I'm at 1%. What do the model numbers mean on how to define them on a filter dryer? Dustin taught me this. Dustin, can you explain?
Does anyone else besides me know what all the different filter dryers are? Like if you ever need to know a filter dryer, but the data tag on the old one is gone.
Off the top of my head.
So if you need to know like the 8, right? Let's do an 83, for example. You have like a 53, an 83, a 33. The 80, the 50, the 30, if I recall, it's like the volume of refrigerant they can travel, like the cubic, whatever it is. And then the last number, the 3, the 4, the 2, is your line size. So a dryer ending in a 3 is a 3/8. What is a dryer ending in a 2?
Half inch.
No. Quarter. 2/8. 2/8 is a quarter. What is a dryer ending in a 4?
There you go, man.
1 inch.
It's a
Half inch.
Half inch.
4/8. So 3 is 3/8, 4 is 4/8 or half inch, 2 is 2/8 or a quarter, 5 is 5/8. So if you never don't know what dryer it is, but you know your line size, or obviously the cubic volume or whatever is going to depend on the size of the system. I don't really know. I'm not smart enough to be an engineer and say like, oh, it has to be this many cubic feet per inch or whatever. But just if you ever need to know for like sizing purposes, that last digit is a fraction of an eighth, and that will tell you your dryer size.
As far as the cubic inches goes, I've heard it's always better to go bigger than it is, like never go smaller. You can match, but it's always good to go bigger.
That's what she said.
I was gonna say that one.
Well, I'm glad Matt said what he had to say before his phone died again, because he's gone again.
Evaporator wrap up. Inspect all evaporators for proper feeding pattern and cleanliness. Inspect all the fans, motors, blower wheels, proper operations. Inspect and verify the defrost components, heaters, clicks on switches like Dustin was saying, defrost terminations, time clocks. Back to what like Dustin and John were saying, like if you get to like those walk-in freezers, you open the door and there's those little like droplets on the ceiling or all over the place or on the product. Most likely like you're looking at the defrost termination or fan drip time not working properly. So
On the termination too, if you ever have like a freezer and you put it into defrost on the time clock and it goes right back into refrigeration, don't assume it's the time clock. If it has a termination, pull your X wire off your termination on your time clock and retry it. If the time clock stays in defrost, then you know for sure you have a bad termination. Actually, we had one guy, and this wasn't here at Coltech, but had a guy say, "Oh yeah, the time clock's bad. I put it into defrost and it stays in refrigeration." And he changed the time clock and left. And then another guy went back a few days later, said, "Oh, this time clock's bad." Took it back to GA for warranty. And then a few weeks later, I got another phone call and he's like, "Man, something's not right here. Like this is bullshit. Like I just got the third bad time clock from GA. This time clock's bad again." I'm like, "Hey, I'm sorry. Like, there's no way we got 3 bad time clocks like in like a week's window here." And so I went over there and I was looking at it and I had my meter on and I put it into defrost and I saw my voltage go from 208 to 0 to indicate it closed. And as soon as I looked down and looked back up, it was back to 208 and open again. And I'm like, okay, something's weird. Like I literally watched it close. My defrost energized for like a split second. And so I know the defrost worked. I know it went into defrost. And so I pulled my X wire off the termination, tried it again, and it defrosted just fine. So we went through 3 time clocks, pulled the X wire off, wrapped it in wire nuts, went and ordered a new one the next day. So if you ever do have a defrost time clock that seems like it kicks it right back out, if it has a termination wire, pull that off and check it again before you condemn the time clock.
Mm-hmm.
That's one of those defrost clocks go out.
Mm-hmm.
Actually start to put the glass of dust protective box. So,
All the dust and crap wasn't good on them.
yeah, so then they don't seize up. They don't have issues.
So compressors. If compressor's not running, do you have power to your contactor or starting components? contactor coil. Are any of the safety strip, low pressure, head pressure, dual pressure controls? Check those.
How do you know if your pressure switch is open or closed?
Look it.
Check your power.
Check continuity across it, or check for voltage drop across it.
So what should the voltage be if it's closed?
0 across it. Or 120 or whatever it is on each side.
So if it's one, let's say it's 120 and it's closed, you have 0 across it, right?
Yeah.
What do you have to ground on each side?
2 ground on each side is 120.
So what if it's 208? What do you have across it?
120.
You have 120 across it?
Oh, across it? Nothing. I thought you
What
meant
do you have to ground on each side?
120.
Okay.
What do you have
So
for like
now, let's just say it's open, right? If it's open, what's your voltage across it? If it's, 120.
120?
And what do you have to ground on each side?
120 on one side and 0 on the other.
And what if it's 208?
Same thing.
Do you?
Well, maybe not. Probably only
Well,
switching.
If it's 208 and it's open, what's your voltage? Across it.
Across it, it'll be 120.
208, right? If it's open.
Yeah, but it's a split phase, right?
You're getting both legs, so it'd be 208.
Yeah. And then what do you have to ground on each side if it's 208?
120.
And it's open.
It's only going to control
0.
one leg.
You still have 120 to ground on both sides on a 208 switch if it's open, because it's always back feeding through the second leg. So that's why don't make the mistake of checking just to ground. You have to check across it. If you've got voltage across your switch is open. If you've got nothing across your switch is closed. But again, I only know because I made the mistake. I had a solenoid coil and it was not working. And I told my manager I got a bad solenoid coil. And he's like, well, how do you know? And I'm like, well, I've got 120 volts to ground on both legs. And he's like, well, what do you have across it? And I didn't check. And it was 0 in this scenario. The solenoid's a load, but it's like the same thing. 208, if your switch is open or closed, doesn't matter. You're going to have 120 volts to ground on both sides. So you have to check across your switch. You have to check across your load, like if it's a motor. Like if it's a 208 volt motor, great, you have 120 on your leg of power and you have 120 on your other leg of power. But do you have 208 across the load, or do you have 0 and your switch is closed? So just don't let 208, 120 is so simple. It's either hot or it's not. 208, both legs are always going to have 120. You're never going to have just 0 to ground on a 208 volt circuit unless both lines are disconnected. Does that make sense to everyone?
Mm-hmm.
Yep.
Thanks, Dustin.
You're welcome. Sorry, I was in mid puff.
Check compressor operation. After checking the temp, inspecting the evaporator, you move to the compressor and condenser. When inspecting the condenser or compressor, back to your senses. Use your senses. Can you hear? So hear the compressor, is it running, or is just the condenser fan running?
Or
So
it's scroll in reverse.
or if it's a scroll, is it in reverse? We've all been, I think we've all been on calls where we walk up and we just have the condenser fan running. So back to what Derek said, does it sound okay? Like the scroll compressors, they need to be running a certain way, clockwise.
I don't know.
I think it's clockwise, so it's spinning. It's hard to explain like the sound of it, but if you hook up your power backwards, it would be running in reverse, and you can hear it sounds terrible. So
You definitely know the sound.
Senses C. So is there oil in the sight glass? Back is the paint or identification discolored from excessive heat, or is there flood back? Back to the paint. I had one of the compressors at Costco. The head of it wasn't the same color as all the other paint, and it got really, really, really hot. So, touch the head of the compressor. How should it feel? Is it really, really hot? Is it cold? Touch the oil pump. If you have like a oil pump on it, like a supermarket or rack compressor.
Standalone semi-hypnotic.
Feel the suction and oil lines. I put refrain from touching so you don't get blisters or burn yourself if it is too hot. So
Use the back of your hand, then you're fine.
back to the hand.
So I like that you mentioned like the 3-phase power and the compressors running backwards. I think it's just a good thing just to remind everyone that if you're changing a 3-phase motor or a compressor, you always got to verify rotation. Not even just compressors, but like blower motors on a 3-phase RTU. You know, you could have a brand new RTU. Like, I mean, everything's going to work fine, right? You know, it's going to work right out of the get-go, hopefully. And you're just going to land 3 wires of power to it and not think twice about it. But there's really no way to know, like, when you land those 3 legs of power, what the rotation is going to be. And so always verify, like, your rotation of your compressors. That's why when you do a startup on, like, an AC unit, you always check the blower rotation. You turn it on, you turn it off, you make sure the blower is spinning the same direction as the arrow. You check your refrigerant pressures to make sure your suction's dropping and your discharge is rising. You check your amp draws. You know, same thing. Like, I ran a call at Jackson's in Reno, and they said their unit was only like a year or 2 old, and they said it never worked from day one. And it always iced up, and it never did what it was supposed to do. And this unit sat up there running, the fan was running the wrong direction the first like 2 years of its existence. And so just keep in mind with 3-phase, if something is running the wrong direction, just take one of the legs and swap it with the other. Move L1 to L2 and L2 to L1, or L2 to L3 and L3 to L2. But whenever you're messing with like 3-phase power and not single phase, always verify like rotation and direction. You know, whether you're replacing a motor or doing a new install. You know, that's why startup and double checking our work after we complete something, whether it's an install or a service call, especially with 3-phase power, and make sure our directions are correct.
I kind of have something while we're on the subject somewhat. I was wondering if everybody knows how to check resistance to identify terminals on a compressor if you don't have a wiring diagram using your meter.
Enlighten us,
No.
Matt.
So obviously the terminal with the lowest amount of resistance is going to be your neutral, and your start is going to be the highest, and your run is going to be the middle one, I believe. And correct me if I'm wrong, but that's how I've been doing it, and it's been working.
So when you're checking resistance, though, you're usually checking across 2 terminals, right?
Yeah.
So
you gotta
how do you
check-
determine which one's the highest when you're going across 2 terminals?
Well, you would have to do them in pairs, right?
Yeah.
Once you do 1 to 2, 2 to 3, 1 to 3, you'll see what your lowest one is, and then you find your highest, your high and your middle, which would be your start and your run.
I believe on single phase compressors, it's been a long time since I learned this, but isn't on single phase compressors, like the ones with the start caps and run caps and relays, isn't like 1 and 2 plus 1 and 3 equal like 2 and 3 or something like that? Like
I
start,
haven't heard that, but it could be possible. Yeah,
like
that could
isn't
add
it
up.
like
I'm not
I think
sure.
it's like common and start and common and run equals like start and run. Like if you add the ohms up or something like that. I don't
Oh,
remember the exact equation.
That's
Yes,
right.
they
That's
do add
correct.
up.
What you just said.
that sounds about right. Looking at the numbers that I get, yeah.
I was just looking at 3.
I don't know if 3-phase has a rule of thumb or not. It's just you hope there's resistance between each leg and you hope they're all open to ground.
3 phases, they're all equal. They're all equal.
Or should be.
Should be equal.
If they're not, then you have a problem, right?
Yeah.
Then it's gonna run like garbage.
You know, we're kind of talking about ohms and stuff too, but same thing with like voltage drop, you know. If you whenever you're checking a contactor, like if you're doing a PM, obviously a lot of PM forms you've seen, at least at supermarkets, they ask you, they say, what is my voltage line 1 to line 2 and line 2 to 3 and 1 to 3? That's great. But what about your voltage drop across your contactor or your breaker from top to bottom? We've all probably have seen the contactors, right, that you can't remove the front cover. How do you know if your contactor is pitted or worn? If you check your voltage 1 to 1, top to bottom, you really shouldn't have a difference right there, right? It's like a switch. If your compressor contactor is pulled in, one on the top to one on the bottom is the same leg of power. It's going through the switch of the contactor. If that contact is making a good connection, you should read 0. There should be no voltage drop from one on the top to one on the bottom. Once you start getting a difference in voltage and you start picking up different voltage readings through top and bottom of the same line, just like a pressure switch, if my pressure switch is open, I've got voltage. If you're seeing spikes and your voltage is popping in and out and you're getting weird voltage readings, top of 1 to bottom of 1 or top of 2 to bottom of 2, there's a good chance your contacts are pitted and are not making a good solid connection. So if you ever can't take off the cover, or what's visual to me might be different than what's visual to Matt. Maybe I see something and it looks a little black and I think, oh, this has got to be replaced right now. And maybe Matt sees something that looks pitted and black. He's like, it'll go another 6 months to a year. Like, it's cool. I mean, that's just my judgment versus his judgment. But verifying that you have 0 volts on your meter from top to bottom across any disconnect, contactor, switch, you know that your switch contacts are good. So when we're doing PMs, don't just check, oh, I've got 208 coming in. You should be 0, like top to bottom. But yeah, just in case no one's ever checked that.
On that note too, I've also seen voltage drop across fuses on disconnects. Not very common, but I have seen it.
Yeah.
Yeah.
Which probably indicates either a weak fuse or your fuse holder is not making a good connection.
Resistance.
Yeah, it's usually the fuse for me.
If the compressor not running, is the compressor tripped off on oil fail? What should you do before you reset? So like oil fail, like a lot of like the semi-hermetic, like Costco's, a lot of grocery stores, they have the oil fail. If you notice
Check the sight glass.
yeah, do you go and just push the button and reset it?
I usually ask someone else to reset it and I hide around the corner.
Make sure the oil didn't go to another compressor.
Correct.
I mean, I would want to make sure that there's actually oil in it before I reset it. That everything electrically checks out. What are some common causes of an oil fail?
Dirty oil.
The dirty oil. What else?
Yep. And that screen
Right.
inside the pickup that it will plug and it will cause a false fail even if there is oil.
What else?
Low refrigerant.
Okay. Usually, if you're low on refrigerant, you also have a chance to be being low on oil too, huh?
Mhm.
So what else?
You don't just dump oil in the system though, because you could end up putting tons of oil in the system, don't need it. Low pressure, like I've seen some where it's just cut out and refrigerant isn't coming back because it's blocked from getting back to. So just blockages in the
Yeah, the oil
refrigerant line.
separator or the oil float.
Yeah, you could have that. An oil filter could be restricted, right? What if some dingle hopper decides to install a new evaporator and the condenser is 20 feet in the air and they don't put a P-trap on their unit, on their evap?
Yeah, then it's stuck in the.
That P-trap is designed for oil flow. It's not for refrigerant flow, it's for oil flow. What are some other things like Matt Garabrandt? What else can cause an oil fail?
Air Bear.
I'm trying to think of something new besides what you already mentioned.
I know this is kind of different because a lot of the self-contains and single system we work on don't really apply to this because they're usually sealed systems. But you know, for those of you that are getting more involved in rack systems, oil failures are very common at like supermarkets or non-bigger systems. So, you know, what are some other things we can think of that would maybe cause an oil fail?
At Costco?
Okay.
It could be the suction screen also, that plugs and the oil can't get back to the compressor.
Okay. What about like our superheat? How can superheat cause an oil fail?
Well, if it's too low, it won't bring it back. Right or wrong?
Well, if it's too low, what do you have? What do you have coming back to the compressor?
Liquid.
Huh?
Liquid.
Yeah.
Liquid. So compressors aren't designed to have liquid in them. So if you got liquid coming back to the compressor, if it's bad enough, it's going to just push the oil out of the compressor and push it out into your system. Especially at supermarkets. You know, you've got 20 different systems on a rack. All it takes is one of those systems flooding back, you know, to wipe out your oil out of your compressor. You know, Matt's experience with that at Costco, to have to basically start at your suction header and say, okay, my superheat at my suction header, which we've talked about this in some of the previous classes for the guys that were able to attend them. What should your superheat at a compressor? What's the minimum superheat at a compressor?
35, 40.
20. 35, 40 is great. But like Copeland, for example, you know, Bitzer, minimum superheat. They don't want to see less than 20. When you get that low suction temp alarm at Costco, it's because it's looking at superheat. Low suction temp means your suction is too cold, which means your superheat is too low. So let's say we check our superheat at our compressor or our suction header, and it's 15. Now you got to go through and figure out which system is flooding back. I always start with, if there's one system and it's a ball of ice, I'm going to start with that one first. And you're going to work your way. You're going to go suction line to suction line, checking superheat. And anything below that 25 to 20 mark, I'm going to start with those ones first. And then you have to go out and you have to adjust all the valves for those. So floodback is a big cause of superheat, of oil fails. And it's a hard one to catch. Those are the ones where the guy goes and they reset it and it runs fine while they work or while they're there. But then guess what? That system goes into defrost. It's nice and hot. It comes out of defrost. The expansion valve opens wide up to cool it back down. And it's already running low superheat, but now you're like sending so much liquid back to the compressor, you're pushing the oil out. So that's a really common one. You know, Walmart Twin Falls, for example, they've got, you know, their system. It's not a rack system. It's still just a single system. So it's not only at grocery stores, but those have oil fills on them. And it's the same concept. Too low of superheat can cause oil fills. Another one I've seen is contactors. A supermarket specifically, you know, you guys are all probably familiar with proof switches on AC units, right? looking for proof that your blower is running, or proof that your fan is on, or proof that your inducer mode is running before your flame ignites. You know, a lot of supermarkets, they have the same thing. The computer is looking for proof that your compressor is running. If your contactor is not pulling in, there's no amp draw, there's no proof your compressor is running. So as a safety, it will time out. I believe it's 2 minutes is what those are usually set for on the oil fills. If you're not sensing correct oil pressure after 2 minutes, it'll trip it out. If you keep your control voltage on and you walk over and you shut off your breaker to compressor 1, but the computer is calling for compressor 1, if you leave it that way after 2 minutes, your compressor will trip on oil fill. Even though there's no power going to the actual motor itself, it tells it it's supposed to be on, but your oil pressure is not there, and it's still going to require a manual reset of your pressure control or your oil fill control. So I don't know. I'm sure there's other reasons, but I don't mean to like talk everyone's ear off either, but it's just stuff that, you know, you might not see it tomorrow, but when you do see it, you know, are you going to know like what to do?
Mm-hmm. Other safety, whatever piece of equipment you're working on, you have to identify the safeties and use meters to check them. So, like sequence of operations and like wiring diagram, follow through. And if you're not getting power to your contactor coil, kick the compressor on. Like, look at your schematic or follow the wires and see what's actual, like what safety is controlling it, or solenoid or thermostat. So, condensers. After inspecting the compressor, condenser needs to be inspected. Type of condensers you're dealing with, determine the type of inspection required. So like condensers, you have like the microchannel condensers, which those get clogged way easy. If it's summertime, all the dust or certain areas, like Derek said, cottonwood. Texas Roadhouse here, they have 3 cottonwood trees right outside, and every 2 months or a month in the summertime, they go up and they wash them themselves because they get so caked on. And
Or the hospital is right next door to a potato field, so every time they go plow the field or whatever, they call it the micro channels, just get
all
full
the
of
crap
mud.
gets in.
Yeah.
Mm-hmm.
What about hydro coils? Water coils?
Mr. Like cooling towers, I guess.
No, like if you're working on an ice machine, it's got a water coil. It's
Oh,
not very common. The Helix.
Yeah. So that one, Derek pulls a good point. So like on those ones, like water cooled condensers on ice machine, check.
Or water source heat pump.
Water source heat pump, like so. Check your temperature, inlet temperature of the water. Make sure it's not on the same water line and teed off to your ice machine. And check, just like Idaho Falls, Ammon here, we have like extremely hard water. So if you have a water source condenser, chances are that sucker's run for 10 years and that coil's all gunked up and plugged with stuff. So
there's nothing you can do.
Yeah, it's kind of similar to like our Albertsons here in Boise with glycol. Like usually those water cooled condensers, you even see on single systems, but they always have like a regulating like pressure switch type thing that you adjust to adjust the flow of the water. Because obviously, if you're not moving enough water, right, you're building up more heat. You're gonna have higher head pressure. So you also, if you are working on like a water cooled condenser, you know, having it set for the proper pressures is important too.
I like to check subcool on water coils too. Not just
Mhm.
water outlet, but subcool.
I was actually working on some Stolting units, got called to West Yellowstone. And all their Stolting units were water cooled. And they had somebody come in and install an ice machine. All of a sudden, none of their Stoltings were working.
Oh, they stole.
They stole the water off the same line. And the ice machine sucked. Every time it kicked on, it still all of the water. They weren't happy to find out that there's nothing I could do except for turn off their ice machine.
Josh, what do you got, sir?
Oh yeah, I just wanted to comment on that water cooled. Just another thing to check is your differential between your inlet and your outlet. Just to verify, I mean, you're probably going to be in the 10 to 12 degree change from your outlet, which is just a rule of thumb. If you come across that, just for the other guys, just so they know. I don't think we got much here, in Boise, but just as a rule of thumb, just see what your differential is, and if it's too low or too high, then like Dustin said, you got to adjust your valve to get that temperature because it's running on the pressure.
Make sure you don't
Correct me
back
if I'm
way out of that
correct
water.
me if I'm wrong. I think the aren't those electro freezes the same way at like the Dairy Queens and like your Culvers and things like that? Don't they have like a water cooled condenser portion?
Some of them.
It's 50-50 like everything else.
The one I did was air cooled, but it does have EEPRs. Well, not E, but just E.
Yeah,
Yeah, just,
Mhm.
but it's in 2 E's. My bad.
I was also gonna ask, does anybody have a lot of experience with the liquid injection to like the head of the compressor? Because like I just worked on my first one the other day and I had to call Matt and I didn't know what the hell I was looking at.
Is anyone that was worked on the one at the Flying J recently on the call? Was anyone with Joel at Flying J?
Yeah. It's basically just a second small TXV that as the compressor gets hot, it sends liquid into the compressor body.
I've seen two different types, really. Like, I think the older type is usually just like a sensor that goes in the top of the compressor. Then there's a solenoid valve. When that compressor reaches a certain temperature on the head, it energizes the solenoid and meters in a small refrigerant. All the new ones, though, they've switched to an expansion valve, where essentially your sensing bulb is now in the head. You don't need the solenoid. Some of them have the solenoid, some of them don't. And then, like Derek said, when it reaches a certain temperature, you're just slowly metering a small amount of refrigerant in to keep the head down. I think it's usually only on like the scroll units, right? Just because they run so hot, like you won't see it on some of the older like K-body style ones, but it just keeps the heads of the compressors cool. Like there's an internal temperature rating, and if it starts reaching that, that it just feeds a little bit of liquid off your liquid line in there to cool it back off.
But really, you shouldn't rely heavily on that. You need to get your superheat right to have cool gas cooling your compressor, right?
Yep. Does that help, Jeremy?
Yeah, absolutely. Like I said, I had to ask Matt and I asked Nick, and I was like wrapping my head around that theory. Like, well, how does that work? Like, how does it, because surely that liquid isn't cool enough, but then that makes sense. It's being metered into the compressor, basically just like a TXV would. So that makes a lot more sense.
Yeah, I think the old style, it was like a timer or something where it like would energize the solenoid and dump a certain amount in and then check the temperature again. And but everything switched into the expansion valve style. If I recall right, the one that Joel and whoever did at Flying J, they had the old style on the old compressor. And so, that was one of the questions, like, hey, like I got this solenoid, but now I have this expansion valve, and where do I put it and what direction does it go in? And it's just a compressor safety type thing.
They're starting to put them on Mitsubishi mini splits as well. And I think he said when I went to the training that they were going to be an electronic expansion valve controlling flow to the compressor. So now you have 2 EEVs to deal with on one unit. So that's fantastic.
Huh. I uploaded pictures on the chat too. That shows what we're talking about too. So just one version of what it looks like. So
I don't know about anyone else, but I personally have never had to adjust one of those valves. I don't know if anyone else ever has, but I've never had to adjust one.
Never have.
Never have either.
Theirs just go bad. Ones that like Winco on the protocols went bad a lot.
Make them go bad, do you know?
That was when I was a little peon, so I'm not sure.
Who knows?
I got told to replace it, so
It was bad.
I just replaced it.
That's all I did too.
That is something though. We could be asking why a whole lot more.
Fan motors, belts, and cleanliness. Check the motors. Stage them manually and look for proper balance and operation. Check belts and bearings. Make sure bearings are properly greased. I'll get back to that one. Check belts for glazing and cracking. Check for proper alignment. Check the sheaves for improper wear and alignments.
Or brakes.
Or brake. Who posted that?
That was Jeremy.
Yeah. Or brakes like Jeremy found. One of his calls. So back to like properly greased. Like what is when you're greasing a bearing, what is properly greased? So like a lot of people squirt it in, few pumps, or they'll pump it, and then it's like oozing out of the bearing. And when it turns on, you got grease flying everywhere.
I don't know the right answer, but I was taught you always like pump it in until you barely see it break the seal.
And then
That's what I've been told too.
Yep, that's it. Just one little, like, barely doing it. So
then after you pump it in, always wipe the tip. I don't know why you're laughing. The tip of where you had, your little nipple thingy right there at the end. You just don't just leave all that old grease on there. And I know we've talked about it before, like in our last meeting about like PMs and stuff. Like,
yeah,
I feel like that's an area a lot of us were missing. I don't feel like all of us had grease guns. And, it's one of those things, I didn't bring it on the roof. Like, we'll get it next time. But sometimes next time's too late. And then we're out there changing poor Josh is driving out there in the middle of the afternoon on a Saturday and has to go do it on the weekend. Huh, Josh?
Yeah, it's fucking bullshit.
I'm glad you used subtlety.
So check the sheaves or pulleys. Like you also check, like should they be even? Should they have grooves on them? Like there shouldn't be any.
Should be smooth.
Any grooves or bumps, they should be nice and smooth. So like if you're on a maintenance or a call, like grab your nail and like touch it. If it's all jagged and messed up, like put a bit in to replace that. So proper condensing. High head pressure, high temperature, vapor enters the top of the condenser from the compressor. So like your head pressure. So depending, say it's summertime. There was a call somewhere where AC wasn't working. Went and like changed the belts, checked everything, but we never cleaned. We checked the condenser and it looked clean, but we never washed it. Yeah, like some of the like condensers have the two coils. Like, oh, it might look clean, but when you wash it, you have to wash it and look and see how much you get out of it. After it looks clean, you can see daylight, but all that dust and dirt still restricting it, causing that high head pressure, high temperature, which it's not gonna condense properly, so creating the issues.
Yeah, I was gonna mention too, some of those condensers, they have split coils.
Yeah. Uh-huh.
And you gotta pop the top on those and peel it apart and clean the in between, because the dirt gets stuck in between the two.
Mm-hmm.
It's cottonwood seed. I don't know if this is kosher or not, but just taking a lighter to the bottom of it does a really good job.
You'll find out if you have a leak.
Yeah, until you realize it was a propane unit.
There's a leak.
I'd be so happy if they put propane in AC.
Jeremy and Nick worked on one at Five Guys today, so I would advise not using a lighter around that unit for the next couple weeks.
Nick did use lighter, Dustin. So.
Yeah, he kind of did. He? Did he actually? Yeah. That's hilarious.
Yeah. Flash gas. What is flash gas? What causes flash gas? And how do we know flash gas is occurring in the high side of the circuit?
I guess you're going to tell us based off of the quietness.
Yeah, I'll tell you. I messed up on this slide, so I didn't put.
And that's like Googling it really quick.
I am. I didn't put the answers on it, Dustin. Okay, come on.
Flash gas is when you have liquid boiling off inside of the liquid line, right?
Correct.
Which is caused by low subcool, which is usually a condenser fan motor or a dirty condenser. Or it's just way too freaking hot outside.
Correct. So like the heat transfer entering it, so causing dirty condenser.
In other words, you want a solid column of liquid leaving your condenser. Flash gas is essentially the situation where you don't have a solid column of liquid. You're getting flashes of vapor still, because why? You're not fully condensing your refrigerant.
In the condenser. Yep.
That would show up in your sight glass, wouldn't it too?
Yeah. If you have one.
Except for on 448, and you're gonna flash on 448 anyway.
I don't flash.
You're not, you will, because you've got too many different.
Too many blends in the
Too many blends in the 448 and 449.
glide is too extreme.
Mhm.
You gotta.
Still don't have the issue. What was done a couple?
Next one, H. So heat load. So back to like superheat and subcooling. So get the refrigerant saturation, pressure, temperature. Take the pressure reading of the liquid line leaving the condenser. The refrigerant saturation temperature is the pressure temperature when the refrigerant is turning from the high pressure vapor into the high pressure liquid, giving up heat. At saturation pressure temperature, both liquid and vapor are at the same temperature. One, convert pressure to temperature with a PT chart. What was it, Dustin? What was it was Costco, Idaho Falls, the microthermal was reading only the PT chart of Bitzer, right?
Vaguely rings a bell.
Something like that. So it was reading when they programmed their crap, they programmed it off of the Bitzer's PT chart, which that was slightly different than Danfoss's PT chart. It was really
pieces, which
yeah,
is where the issue was.
or field piece, yeah. So it was really off. We're if you're using your field piece wireless gauges, the actual PT chart they use is different. So we had to use all the kick it old school. Take a temperature reading at the liquid leaving the line at the pipe, leaving the liquid line of the condenser. Compare both the saturation temperature and leaving liquid line temperature. Subtracting one from the other is the difference is the amount of refrigerant has cooled past saturated temperature. So that would be your subcooling. Using H to finish troubleshooting. So when applying H, you will need temperature clamps, PT chart, refrigeration gauges, and knowing how to properly check superheat and subcooling. Still think everyone, I even struggle doing superheat and subcooling sometimes. That's one of superheat and subcooling are, I think, one of the easiest, but yeah, hardest things people struggle with to figure out on some calls or cases. It's about measuring evaporator superheat. So get the pressure reading off of suction line, leaving the evaporator to get the refrigerant saturation pressure temperature. Refrigerant saturation pressure temperature is the pressure temperature when the refrigerant is turning from a low pressure liquid to a low pressure vapor, absorbing heat. At saturation pressure temperature, both liquid and vapor are at the same temperature. Convert the pressure to temperature with PT chart. If your reading is attained at the compressor, not at the evaporator line leaving, you will have to add a few pounds of pressure due to pressure drop in the suction line. So if you're on a rack system, you can check at the EPR, check your superheat there, and add a few pounds
Friction of the line.
For how long the line set is, if there's insulation ripped, all that stuff. Take a temperature reading at the line, leaving the suction line of the evaporator. Compare both your saturated temperature and the leaving suction line temp, subtracting one from the other, and that is your superheat. The last few slides, I just put, I don't know if you can read them. So here, just KE2, wiring.
Like the little ones.
Yeah, the Air Plus, the Air Plus defrosts. So, just as a basic, layout of the refrigeration cycle, kinda. So.
Take a picture of that. Put it on
From the chat. Okay.
It's kind of hard to see there. I don't know if it's hard to see everywhere.
Yeah.
Okay.
So basically, you have your compressor and your discharge gas going in the condenser and come back. Then you have your your thermostat, your evaps, and then you have your metering devices, and then solenoid coil. The K2 Air Plus defrost hooking up the dual voltage. You have the 115, or 240 L1, L2. And normal closed and common. One side of your solenoid coil, go to the normally closed. And then the other line power comes back to your common. Yeah, that one you can't really see. And then I put this. Hey, Ken, can you shut the fan off?
Should really call an HVAC company about that rattle.
Right. And like, I put this as the last slide just as like as like techs, like are like soft skills. So like soft skills for tech, like the communication and talking. So like we have like verbal, nonverbal, listening, using questions, bad news. So like I think 90% of what we do is like soft skills, talking with customers. Like we can say the wrong thing to a customer and like all hell breaks loose. Like we can do a good job on everything, but we say like one bad thing, like, oh, whoever the last company out here, or last person, or last tech, can really like screw everything up, lose a customer. And I think like 90% of it is soft skills, and the other 10% is actually working on the equipment or fixing whatnot. And then like professionalism, appearance, customer service. So like appearance, like you don't want to look like my opinion, like you don't want to look like a bum or like your vehicle or your appearance is a mess. And some customers might think like, oh, you're working on my equipment, like you can't even keep yourself clean.
You've not even got both your boots laced up.
Yeah, so but that's all I had. If anyone has anything else they want to chime in about.
No, I just want to say thank you for taking the time to put all this together. I'm glad we started doing this again. I actually just enjoy hanging out with you guys and talking about refrigeration stuff. It's a nice break from dealing with grouchy customers and everything else all day long. And little bummed no one in Boise's here with me hanging out, just here solo still. No one wanted to come hang out with me, so probably pissed everyone off at our long meeting the other day. But just, I don't know if everyone saw the messages, but did receive some good feedback from customers the last few days. So, just want to say thank you to all of you guys. And, we're just always looking for ways to be better. And so if anyone has ideas for next month's training, like let's just make sure we're staying on top of it, and let's get that one set up and maybe try to do something more hands-on. I know Matt put this together, so maybe we can just continue with like diagnosing and like go into more electrical and do the more hands-on, like mess with those boards and stuff and wiring diagrams next month, if you guys are okay with that.
Sounds good, Dusty.
Sounds really good.
Yeah,
Cool.
let's get in the shop.
So sounds good, you guys. Well, hope you guys all have a good evening, and well, I'm sure I'll talk to you guys tomorrow.
And thanks, guys.
Hi, Matt. Bye, Dusty.
Hey, Dustin,
Yeah.
what you sent us all our numbers, but I don't know what they mean.
Who's asking right now?
Derek.
Oh, I can kind of do like a quick review if you guys want.
I mean, yeah, if you just want to go over what each of the numbers means.
So just so you guys know, I only sent them out to you because a lot of guys want to know more than just revenue. I'm pretty sure when you guys look, Service Titan tells you guys revenue, right? That's pretty much it.
Yeah.
Let me see if I can find it here really quick.
It's also got conversion rate, but I don't know what that means either.
So conversion rate, we wouldn't even pay attention to conversion rate because that's not on my report, right? That's just Service Titan, right?
Yeah.
So conversion rate just means the number of estimates that you've built that have been sold. I pay no attention to that. I mean, we're not salesmen. We don't really keep track of who sold the most estimates. I mean, obviously, like a high conversion rate could mean you got very few quotes built, but you sold all of them. Obviously, we always want to pick up more work if there's things that are wrong outside of our scope. Yeah, sending quotes is great, but that's what conversion rate means. So what I did is it took me like 3 hours to find all the information in Service Titan to put this together, but I just wanted to be able to give you guys just an overview of what 2023 looks like. Wanted to show that it's not just all about revenue. Honestly, I feel like everyone did pretty good in these numbers, but so the first column was revenue. Obviously, it varies. Some guys haven't been here as long. Service Titan is very flawed because if Derek sells an estimate and Ken does the work, Derek still gets the revenue because he's the one that built it. So it's not perfect. So I don't really worry about revenue. Revenue per job hour is more so for if every hour you're clocked onto a job, basically divided by your revenue, that's how much revenue you're producing an hour in comparison to your total revenue. Some guys were really high, some guys were really low. But again, I mean, Jeremy, I'll pick on you. You first started and you got put on Natural Grocers. It's a set price construction job that we were way over. So chances are a lot of Jeremy's hours got removed from the job. That doesn't mean Jeremy's performance is lower. So that's why I said I only sent this as informative, by no means, judging or grading anyone on it. But when we get our new software, like it is going to be nice to see when we look back. GP per job hour. So does anyone mind if I go off of their numbers for examples?
I don't care if you use mine.
Okay, so let's just use Derek for example. Derek, $261,000 in revenue. Great. Revenue per job hour, $235. GP per job hour is basically how much Coltech took after paying Derek and paying our vendors for any parts. Derek's GP job hour, so revenue 235.60. Every 235.60 that Coltech made as Derek is a technician, Coltech kept $130 of that. So when you do the math between those, that's 55%. Coltech is keeping 55% of the revenue that Derek generates per hour. This category, GP percent per hour, And when Matt's looking at jobs, when I'm looking at jobs, in order for Coltech to be profitable, our GP needs to be 50+%. And I'm proud to say that every person here's GP is above 50%. So that's hours you're clocked into jobs. And then when you go to revenue per paid hour in GP per paid hour, everyone's numbers drop because one, there are factors you can't control, vacation, PTO, holiday, but this is also like non-billable time, or if multiple guys are on a job and we can't bill for both guys, then obviously the technician's still getting paid, but the customer is not. So your revenue in GP per hour or for 2023 drops. On average, for every minute the guys were clocked into jobs, when you're on a job, our GP across the board was above 50%. When you look at as a whole for what technicians were paid, our GP then varies. We had as low as 22% and as high as 50%. In theory, if we can keep both of those numbers above 45, 50%, like we're doing fantastic. Does that make sense so far?
What was that, Dustin?
Does that make sense so far?
Matt was distracting me. Everything that you've heard that you've said that I've heard made sense. Yes.
Yeah. So obviously your GP drops for when you go off of how much you've been paid because of all the different factors and not being able to bill time. All these numbers are going to vary person to person. I feel like the biggest one that probably has like the most value is billable efficiency. That means what percentage of your time that you're on a job is billed to customers. Yours is really high, 131%. So what are some scenarios that we could maybe have above 100% billable efficiency? I mean, it could be as simple as we double bill our customer like we did for some stupid PMs here in Boise. They got billed twice accidentally for PMs. So obviously, if we're billing more than you're working, then your number's going to be high. It could also be high too, because if you do a quote for 8 hours and you finish it in 7, there's an extra hour. So that's fine, but I just like to explain why it would be above 100%. The goal here is to have everyone above 90%. But that's just basically out of a percentage of your time that Coltech is paying you, how much of that is getting billed to a customer. Our lowest numbers are in the 40s and 50s. Our highest numbers are above 100%. So as we grow and train and we learn and we correct our mistakes and we don't have to credit as much stuff and we can get all of our time billed to a customer. This one was a big one for quotes and NTEs. When we go over our quotes, over our NTEs, we can't bill. So the percentage of your time that you work that we can bill to customers goes down. That's really like the most information I could pull and gather out of ServiceTitan. You guys have probably heard us talk about gross profit and GP. Keep in mind, GP is just after technician was paid or just after we paid vendors. So that's what we start with before everything else. So for you, for example, if you make $235 of revenue and Coltech keeps 130 of it, that 130 then goes to pay the office, pay our rent, pay our vehicles, pay our insurance, pay for our benefits, all those things. So you can imagine if all of our GPs were in the 30s, there's not going to be nothing left over by the time we're done paying all those things. So like I said, everyone did fantastic. I don't trust all the numbers because of, like I said, the different circumstances. Guys that are on construction jobs and HVAC jobs and doing cleanup work, reality is we're not making revenue doing that because of the scenario. So that technician's revenue is going to be lower or their billable efficiency is going to be lower. But it's just as much information as I could gather with our current software to give to you guys to reflect on what your 2023 looked like from a financial perspective.
Nice.
But like I said, everyone's doing really good. And, I know we had a big, long meeting, but we don't do these things to like annoy or pester anyone. It's just so we can learn and be better at what we do.
Hey, Dustin.
Yes.
Realistically, is there a scenario in which you would be able to like pull for me, starting in like whenever I actually started doing service and the whole kind of fiasco with me being on construction for like 2 months or 2.5 months is like over, like, so I can realistically see what my service, stats were, if you will?
Yeah, I'm sure I could rerun the report for like the last 30 days or last 60 days or whatever. But again, like your revenue's low, Jeremy, because of construction, but your GP is really high. I know that me and a Boise guy had a conversation the other day about revenue. And he said, like, if let's just say we have a $20 an hour guy and a $30 an hour guy. And he said, well, if the $20 hour guy did more revenue than $30 an hour guy, then why isn't the $20 an hour guy paid $30 an hour? And I just said, well, it's not about revenue. It's about GP. It's about profit. It's about consistency, because chances are the more experienced guy probably did it a little bit quicker or made fewer mistakes. So Coltech probably kept more of that revenue when all was said and done, if that makes sense. So your guys' revenue really doesn't matter. I mean, the goal is 250,000 a tech a year is the goal. But again, I have no way to distinguish how much of Nick's revenue was actually Derek's or how much of Dylan's was actually Joe's, because of how Service Titan calculates like the whole estimate and quotes and stuff like that. So just didn't want anyone to think any of it was negative. I just wanted to give you guys as much information as I could find in Service Titan.
No, I appreciate it. I really like to see, I don't like to kind of like, well, I just do it to do it, blah, blah. Like, I want to see like that I'm making a difference with, the company I work for. So I appreciate seeing the kind of report on that.
Yeah. I just look forward to our new software when the report's more accurate and we have, more information to give you guys.
What is the word on the new software?
It'll probably be implemented after summer, because Coltech is not going to be the first company to get it. We have sister companies that do not currently have a software at all and are still on paper tickets, so they're going to do them first. And they don't want us to be switching softwares come June, July, right in the middle of summer and trying to learn something new.
Okay.
But it has been chosen, it has been worked on, but we're just not going to be the first company to get it.
What service is it?
I think it's called Next Service.
Next service.
It's actually owned by NetSuite, who is going to be our new accounting software. So it'll be really nice to have like everything financially and operationally will be fully integrated within the same platform.
Dave Ramsey promotes NetSuite.
So I'm excited. Just wish it happened sooner. So
Thanks, Dustin.
yeah. Any other questions?
I think everybody got off. So
Okay. Well, love you guys.
bye.
Bye.